Values in JavaScript are already things like numbers, strings, booleans, and objects. Here, we're calculating the number of seconds in a day, 86,400. At runtime, we can use the type of operator to determine the type of the operand's value. Here we see it's a number. TypeScript builds and expands on this. It uses types to catch mistakes before your code even runs. That's its MO. You can see TypeScript in action by simply hovering over the variable in VS Code. TypeScript is inferring the type here. A common beginner misunderstanding is that you need to type everything. Not at all. TypeScript figures types out on its own. We certainly can add what's called a type annotation to describe what type of value our variable can be. We do this by placing a colon after the variable name and the type. Of course, we don't have to do that here. If I were to make this a string, you can see the error right away. It's saying type string is not assignable to type number. To see how this helps us catch mistakes, let's take the square root of our variable. It still works because the string is being coerced, but functions can be typed as well. Hovering over, we can see that functions have parameter type annotations and a return type annotation. Here, this function takes a single number parameter and returns a number. And the error you're seeing, TypeScript is expecting a number, but we're giving it a string. You can also see that the root variable is inferred to be a number, because that's what this function returns. By putting this variable back to a number, the error will go away. Here's a function called square, which simply returns the square of its input. And you can see there's an error over here. It's saying that X implicitly has any type. Any is a special type that disables all further type checking. And this parameter defaults to any because it can't infer its value. It doesn't know what's supposed to be passed. And this is flagged as an error. So let's annotate it as a number. And there's no more error. You can see that number is the parameter type for X, and the return type for this function is number. It is inferring that the return is a number because number times number should be a number. It's inferring SQ over here is a number. I could explicitly set the return type. A little strange for sure. It's telling me that this isn't going to be a string, but you can see that it actually is inferring that this variable is a string because that's what we explicitly said in this return type. And to drive the point of type inference home, if I were to change this to a string, of course everything still works. We're getting an error here saying string times string doesn't really work. You need any number or big int. So let's put it to big int, and I will admit I have never actually used a big int in my life. This is now complaining. To use big int, you gotta wrap it in this constructor. And now the function is inferring that it returns a big int. Here is an object. At runtime, JavaScript simply sees this as an object. But TypeScript asks a more precise question. What kind of object is it? To answer that, it uses an object type, a description of exactly which properties the object holds and what type each property's value must be. Hovering over the variable, we see its type. Object types are defined by listing the properties and their types. Here, we see it's inferring that name is a string and age is a number. Semicolons are used to separate the properties. I'll create a function called sayHi, which takes our user and just logs the user's name and age. We see the any type error again, so let's annotate the parameter type. We say colon, name is a string, semicolon, age is a number, and no more error. By defining a type, we also gain excellent autocomplete and inline guidance, which is one of the major benefits of using TypeScript. It knows there's only two properties, age and name. We usually want to use the same type more than once and refer to it by a single name. A type alias is exactly that, a name for this type. The syntax for type alias is as follows. By convention, we capitalize the type name. And now I can just say that user is a user type. If we explicitly type our variable and add another property, TypeScript throws an error because the object no longer matches the shape defined by this type. If we try to log a type alias, we get an error. User is not defined. That's because in JavaScript, it isn't. Type aliases, along with other TypeScript types, are only used for type checking and developer safety. Once the code is compiled into JavaScript, those types are completely removed, meaning they do not exist at runtime. Here we have a function called tag that takes in a parameter typed as user. The function then returns a new object containing that value as data, along with a timestamp showing when the function was called. But what if we want to tag something like a string? We could change the parameter to a union type, a type made of two or more possible types, meaning the value can be any one of them. But that gets limiting pretty quickly. What about numbers, booleans, or other object shapes? This is where generics come in. With generics, we can declare a type variable, commonly called t, that acts as a placeholder for whatever type is passed into the function. We do that as follows. Instead of hard-coding a specific type, T allows the function to work with different types while still preserving full type safety. You can see that here we're passing in a string. TypeScript automatically infers that the value is a string. When we pass in a user, it likewise infers that the value matches the user type. We can also explicitly provide the generic type ourselves by supplying a type argument when calling the function. We do that like this. Here we're going to set t as, let's say, Boolean. This means that data will be inferred to be a Boolean. Normally, TypeScript infers the type automatically. Providing the type argument manually lets us be explicit about what type we want t to be. You'll sometimes see the same generic pattern when using useState in React. For example, when we write useState true, TypeScript infers that this piece of state is a Boolean because the initial value is a Boolean. But sometimes inference can be too narrow. Here, Because we initialize session with null, TypeScript assumes that the state can only ever be null. It's saying user does not exist in type null. That's why we get an error when trying to set session to an object containing a user. To fix this, we explicitly provide a type argument. This tells TypeScript that session can either be a session object or null, which more accurately reflects how the state will be used. And just like variables and parameters can have types, functions themselves can be type too. Here, fn is a parameter that expects a function. We can type it by describing the shape of the function that we want. In this case, one that takes a user as an argument and returns nothing. This is how we type it. This is called a function type. It allows TypeScript to check that any function passed into repeat has the correct parameter type and return type. One last thing, what is this void? Void means the function does not return a meaningful value. In other words, the function may run code, but it isn't expected to give back data we later use. Technically, functions like this return undefined in JavaScript if nothing is explicitly returned. But in TypeScript, we use void to indicate that the return value is not intended to be used. So while JavaScript still returns undefined, void tells us that the function is meant to perform an action rather than produce a meaningful value. If we were to explicitly say this is going to return undefined, we'd get an error. In fact, generics can be helpful here too. If we have another function, let's call it sayNumber, and pass it into repeat, this JavaScript will run, no problem. But we see this type error. It's saying this function type is not assignable to this parameter type. By introducing a type variable, we can make repeat usable for many different types, while still preserving full type safety. To drive this point home, hovering over repeat, you can see that it's inferring T is a user. Over here, it's using the constant value 10. I'll just say +5. You could see that it is inferring that it is in fact a number.